Welcome, my dear students. This is our fifth lecture of week 6. And in the last lecture, we have deliberated on multiple dimensions of plastics. We try to understand as well as characterize plastics with different attributes, as well as we try to find out some possible options and smarter options for converting those plastics into some useful resources. And we are going to extend that particular class today with more options, particularly where we can convert or co-process plastic with other material. So here we are going to cover mostly your co-processing of your plastic waste as alternative fuel and raw material. We will be also talking about conversion of plastic waste into liquid fuel well, and plasma pyrolysis technology, how this technology is coming up. Although this is it's not available in all the places, but definitely this is a very viable option for converting those particular plastics into some useful material. As well as we will also enlighten on those 3R approach, and particularly once we are going to make this particular resources or these waste material into some useful options. Definitely we need to give emphasis on this particular 3R approach that we will discuss. And most importantly and finally, we are going to talk about the legal framework and the standards on plastic waste management and existing policies on microplastic management in the country, as well as globally what are those options which are available. So what I was mentioning, that of co-processing of this plastic waste as alternative fuel and raw material. So this becomes very popular in the present context. Basically this is involving your waste material, means waste material as fuel or raw material in industrial processes, particularly in cement kilns and power plants. And this becomes a substitute, particularly as a primary fuel and raw material with waste, reducing your resource consumption. So what are the benefits particularly related to this co-processing of this plastic waste? So definitely it covers your plastic waste into alternative fuel and raw material I mentioned, helps cement and power industries reduce your fossil fuel dependency, and reduces the need for landfill space and minimizes that environmental impact, which is going to be a huge contribution in that particular in restoring our ecosystem services. Supports municipal waste management by providing a disposal solution and a viable solution, and utilizes existing industrial facilities, avoiding additional investment in new waste management infrastructure, and contributes to eco-efficient production in cement and power industry, because as if it becomes the power source, definitely it is going to make a huge contribution in this particular field. So if you can see over here, particularly with reference to this primary collection, and then definitely the segregation component in waste is very important, whether you are able to just bring out those particular material, your desired material, and for these your material is definitely your plastics, and that has to be baled. And ultimately it is going to transport it to your cement plant and is co-processing, particularly for producing that much of energy. And the other part, definitely one can go ahead with those sort of material which is biodegradable part. So definitely that can be converted to this organic manure, and the rest, which is, as I said, that which may not be which basically we cannot reprocess it, or we have a very larger period of stay period in soil. So definitely we need to go ahead with this sort of, either it is in cement plant, and the responsibility of those cement plants or cement kilns to use these particular resources as a fuel. And this particular conversion of this plastic waste into liquid refuse derived well, which is coming up of late, but definitely it is going to involve that sort of mechanical separation of plastic waste from your municipal solid waste, and this optical segregation using a conveyor belt to ensure 100% plastic waste separation, and processing through your catalytic pyrolysis. Mixed plastic waste undergoes random depolymerization, and breaking down bonds into monomer, and process occurs in a specially designed reactor in the absence of oxygen with catalytic activities, and maximum reaction temperature is your 350 degrees Celsius. And once we talk about the product formation, the plastic waste is converted to this liquid RDF fuel, basically gases and minimal sludge, and no effluent generation, and unused hot air is released through your chimney. So there are few key steps in this particular conversion process. Definitely the segregation is very important, particularly whenever we used to deal this waste, and if it is plastic, definitely that segregation is very, very important. And optical segregation to isolate those different variants of plastic, whether you talk about HDPE, LDPE and PP and multi-layer packaging material, excluding those polyvinyl chloride, and shredding to remove dust and impurities to make this particular process more efficient, and feeding into reactor for depolymerization and collection of your liquid, that particular fuel and solid waste or charcoal. And this becomes that particular derived fuel which is coming out of this particular process. And this is the schematic diagram. Basically whatever I mentioned just right now, this is just the schematically it is being represented. So in every process I am giving emphasis on that particular issues of segregation. So once you are able to segregate them, definitely you will be able to, and particularly mostly the variants related to your PP, LDP and HDP is given more of use particularly for this context. And these plastics, once it is segregated, then one can use some sort of mechanical machine for separation, as well as the shredding for size reduction of plastics is being done, so that the efficiency of the process or getting that particular fuel or energy is increased. And then beaters for particularly dislodging dust and other impurities, and then cleaning for final cleaning before feeding to it, and then intermediate storage and hopper is done, and then feeder to reactor, and ultimately that particular process of depolymerization is done to convert it into your monomer, because these are long chain carbon compounds. So once it is being converted through the process of depolymerization, definitely we will be able to do that process more efficiently. And then ultimately through this process of condenser and well to storage and dispatch, and whatever sludge is being evolved, that can be also used for some other purposes as well. So in this particular process, three processes, or if we look at the basic mechanism, three things are involved basically, whether you talk about pyrolysis, whether you talk about gasification, or whether you talk about those catalytic cracking or that particular depolymerization, which is very important component in this context. There is another technology which is also evolving, but it's also at infancy stage, but definitely this particular technology is also coming up. This is your plasma pyrolysis technology. The name says everything once you're talking about that plasma, and definitely you need to have that sort of elevated temperature, right? You can use that sort of intervention of high temperature. The advanced technology combining plasma based thermochemical properties with the pyrolysis process, and capable of safely disposing of all types of plastic waste, including your polymeric, biomedical and hazardous waste. That means co-processing is possible. Thing is one can get that sort of outcome out of these, because co-processing, once you have diverse waste, definitely you can go ahead with a single action. And the process mechanism already almost similar. Pyrolysis, definitely thermal disintegration of carbonaceous material in an oxygen starved environment. And then primary chamber, the temperature you need to careful about that it has to be around 850 degrees Celsius. This plastic waste is fit into this particular chamber, breaking down into carbon monoxide, hydrogen, methane and hydrocarbons. And the secondary chamber, basically in pyrolysis, gases are combusted with your excess air, and inflammable gases are ignited with a high voltage spark, converting them into carbon dioxide and water, and prevents the formation of toxic dioxin and furan even from chlorinated waste as well. So once we reach to that higher temperature, definitely the possibilities of formation of these dioxin and furans, which are most likely whenever we are going to handle this plastic waste, one can get rid of that particular issues, that there will be no dioxin, no furan. even if you have polyvinyl chloride, rich plastic material. And if we look at those advantages, definitely it is going to convert over 99% of your organic waste. That means with reference to that efficiency, it's a huge efficiency, and waste into a non-toxic gases, basically carbon dioxide and water, and kills even stable bacteria like, whether you talk about this Bacillus stereothermophilus and Bacillus subtilis. So both of them, it can have that sort of eradicating capability. No need for waste segregation, as an extreme temperature ensures complete treatment of all waste types. So the only thing is we need to have that sort of reaching that particular temperature. You can see over here that particular machine which is basically used as particularly for this PPT, this plasma pyrolysis technology. So here the mechanism which I mentioned, basically based on those pyrolysis and reaching to that different level of temperature and converting it finally to your carbon dioxide and water. So and ultimately reaching to your destination. So whenever particularly in handling this waste, and if it is a plastic waste, definitely we need to leverage the principle of this particular 3R approach. You talk about reduce, reuse and recycle. So these three things are always going to be there. So this is going to be a very, very general importance, particularly this 3R approach plays a very crucial role, particularly whenever we are going to minimize or get rid of this particular plastic waste. Awareness and education are key factors in implementing the strategy effectively. That means the sensitization is very, very important, particularly over here. And also the government policies and public behavior significantly influence plastic waste management as well. So we are going to discuss all these components of reduce, reuse and recycle and further. So particularly with reference to reduction, I mentioned about that sensitization, which is very, very important, and that means we need to sensitize people and for provoking and so that they manage this particular plastic waste in a very responsible way, and encourages a mindful purchasing and limiting unnecessary plastic use, right, and helps conserve resources, reduce energy consumption and lower pollution. And due to the lack of viable plastic alternatives, reduction efforts have faced huge challenges as well, because we don't have any other options. So definitely we are looking for because whatever options are available, that may not be the cost friendly. So several countries have imposed, and even if we look at across the globe, definitely you can see if it is Germany, they have imposed fees like these on plastic bags. 0.05 to 0.50 euro can be put on that particular as a fine. If it is Switzerland and Canada, in 2016 they have introduced taxes on plastic bags, reducing demand by 80%. And if it is Indonesia, you can see over here that it is aimed to phase out these plastic bags by 2018. So initially they started with that particular objectivity, but now they have extended that particular to 2030. And even if you look at India also, in many places in India and particularly in Gurugram municipality where it has been, they have also tried out with some sort of innovations with reference to this reduction policy. They the fine is to the tune of 500 to 5,000 based on the nature of plastics you are using. The next component is going to be your reuse. So this basically you can see from this particular picture that how it can be reused. Using some sensible way, and as well as you can make some sort of innovations over here, helps extend the life of plastic products, reducing the need for new plastic production. And more commonly practiced in developing countries like India, Pakistan, Bangladesh, where plastic grocery bags and utensils are reused and saves money, energy and natural resources as well. And the third component is your recycling, definitely more effective than reuse in reducing the demand for virgin plastic materials. So that can be recycled, can save 40 to 100 megajoule per kg of energy depending on the type of plastic. So this is a huge energy saving can be done, and reduces fossil fuel depletion and contributes to sustainability. Recycled plastic is used in various applications. We have already seen that how those bitumen can be used with this sort of plastics for road preparation, and particularly and those particular, and which is having a tremendous advantages, whether you talk about those infiltration or making holes and ultimately creating many nuisance. So this is going to be, and even toilet structures and pavement blocks, plastones, this plastic based construction material you can see over here. So these are coming up, and this is made up of 30 or 300 plastic bags and 4 to 6 PET bottles per block, and then have high transverse strength, making them ideal for outdoor flooring and compound walls and canal lining. So this is coming up heavily in the last many more years. And you can see over here, based on those diversified group of plastics, you can always based on that, because once you think about those recycling and reuse, definitely this is going to be based on the nature of that plastic. I say those attributes of those plastic, whether it is really possible or not. Particularly if you look at those particular, if it is PP or LDP, so you can see that it can be recycled, and this can also be recycled. But if it is under PS category, it is very difficult to recycle. And if it is something related to your nylon, acrylic and fiberglass, so this is very hard to recycle. But if you look at PET or HDPE or PVC, all these, and even PVC also is hard to recycle, particularly polyvinyl chloride. But if it is PET and HDPE, definitely it doesn't have any issue. So this recycling has to be done based on the characterization or characteristics or that particular the nature of that plastics. So definitely once you talk about all of them, that how it can be converted, but you need to have that sort of legal framework in place, and legal framework and standards on plastic waste management. So there are 3-tier structure. Basically the plastic waste management framework in India is divided into central, state and urban local bodies, with each tier independent and implementing this particular waste management regulations. So these are basically starting from your municipal and informal sector role, and then municipal authorities, they basically manage those plastic waste collection, segregation and disposal, and then consumers are responsible for those particular segregating waste at the source. And there are informal sector as well. Those kabadiwalas are there. Efficiently they collect those recyclables and at the household level, and they can segregate at that particular stage, and it can be reused, because if it is going to be if we are able to put it into some different group of industries, if we are able to send them, definitely it can be used efficiently. And then stakeholder participation is very, very important, particularly once you think about this legal framework. So these key stakeholders include definitely your waste generator, regulator, collector, recycler, and those disposal organization. There are many organizations are also taking care of this particularly some of those NGOs are also coming up. Effective communication between government bodies and stakeholder is necessary for improving these waste management regulations. That means time to time dialogue should be made, particularly with reference to these. And there are sustainable initiatives are there, whether you talk about those United Nations Development Program with those particular Hindustan Coca-Cola bottling plant limited, they have a partnership particularly. So this is a private partner sort of relationship, and for evolving or strengthening this existing plastic waste management system. And this circular economy approach aims to reduce plastic waste through your segregation, collection, recycling and reuse, because that can be always reinforced at all the stages of those 3 tiers we mentioned earlier, aligns with our Swachh Bharat mission and PWM rules of 2016, and also aligning with those particular sustainable development goals as well. And if we talk about those circular economy goals, so definitely it is redesigning products for longevity and recyclability, and eliminating properties that hinder recycling, and incorporating features that facilitate those reuse. If we think about that, yes, within that particular system, if it is capable to reuse and it can circulate within that particular system, definitely it is of win-win situation. And those regulatory measures with reference to India as a major plastic consumer has rules and amendments to regulate plastic manufacturing and consumption. And periodic reviews help track progress, challenges and necessary improvements in this plastic waste management practices. So that means we need to have that sort of a vibrant mechanism, so as to we have a regular sort of dialogue between those policymakers, those stakeholders and those particular person who are using these. And these plastic waste management rules, I was mentioning about those definitely legal provisions, and particularly this came in 2016. The objectivity is implemented to minimize this plastic waste generation and promote your sustainable waste management in India. Responsibility of waste generators, definitely. we need to think about those reduced plastic waste at the source and segregate, store and transfer waste to authorized agencies. There are multiple municipalities who actually collect those, segregated waste material in different, colored container, and pay charges to local bodies for this particular plastic waste management. And salient features of this PWM rules 2016. So definitely it takes care about those particular thickness of that particular plastic carry bag which one can carry, 40 to 50 microns, and plastic sheets to 50 microns. So this has been increased, and there it has also extended the coverage from municipal to rural areas also. Mandatory registration, and particularly those peri-urban areas are very, very important, particularly whenever we looked into this plastic waste management, issues. And mandatory registration and this particular, plastic waste management fee collection from plastic producers and importers and vendors. So there are provisions for those registration and those fees, and encouragement of plastic waste use in road construction and energy recovery. User charges payment as recommended by those local authorities. So that is going to be decided at the local level. And institutional generators and event organizer responsible for waste collection and transfer, whoever is doing this, so they have that particular responsibility of transferring it to the proper, the proper authority. And standardization of plastics. So the Bureau of Indian Standards, they have published Indian Standards codes for plastic testing in 1992. And there is a specific guidelines, particularly for identification, labeling and design, and which are updated periodically. At the same time, in line with these, we have Swachh Bharat Abhiyan. So this is basically, which is Clean India Mission basically, has taken a significant steps to address this plastic waste management as part of its broader sanitation and waste management goals. So objectives basically is almost similar. So we wanted to reduce the plastic waste littering by raising public awareness, those sensitization drive about proper treatment and disposal. And this plastic waste management campaign, Swachhta Hi Seva Hai. So this is, that was the initiative, efforts were made to eliminate those single-use plastics and promote recycling. And basically, it was, encircled with that particular motivation with awareness drive. There was compliance with rules, whether we are, going ahead with that PWM 2016, and also encourage people to come up with some sort of innovative solutions, whenever we talk about those recycling. So this comes under the whole purview of Swachh Bharat Abhiyan. So there are multiple projects are also available under this. So implementation strategy for rural areas also with that sort of similar spirit, segregation, collection, storage and transportation of your plastic waste, and distribution of recyclables, and register your recyclables particularly to your registered recyclers, an awareness campaign for stakeholders about their roles and responsibility. So almost similar, which is done in urban areas. Similarly, things have been initiated in rural areas as well. Prohibition for open plastic burning to prevent environmental pollution. And infrastructure development, definitely at the village level, we need some waste storage facilities, and district block level, there are material recovery facilities and plastic waste management units who is going to handle this sort of plastics, once it is being segregated, and then it can be sent to, proper authority. So there are, multiple policies across the different parts of the, globe. We have multiple policies people have enacted. There are almost 115 countries who has commissioned that sort of policies, particularly in line with or to just address these issues of pollutions of your plastics as well as management, as well as the recent one, the microplastics. So the first one is definitely your OECD recommendation, which basically focuses on reducing microplastic pollution from textile and vehicle tire, proposing a life cycle based strategies. There are Stockholm Convention as well, targets persistent organic pollutants including microplastic by regulating their production and disposal. We have United States 2015, this is basically Microbead Free Waters Act, prohibits the production, packaging and sale of these rinse of cosmetic products containing these plastic microbeads. We have European Commission for Plastic in Circular Economy 2018. So this is basically dedicating approximately 100 million euro over 2 years to promote recyclable plastics, improve recycling processes and eliminate contaminants from recycled materials. We have Basel Convention, which basically expanded its scope to include plastic waste, indirectly addressing microplastic pollution. European Chemical Agency 2020, and they have suggested broad restrictions on microplastic, aiming to prevent the release of almost 5 lakh tons of microplastic over the next 20 years. UN Environment Assembly 2022, they also adopted a resolution to end this plastic pollution and create a legally binding global agreement. And in Plastic Waste Management Second Amendment, if we look at India in 2022, enforced full ban on all single-use plastics. This is a major step and a requirement to increase the thickness of plastic carry bags to above 120 microns. European Commission 2023, the REACH restriction targeting microplastic, basically 30% of your microplastic reduction, deliberately incorporated into products and introduced a regulation aimed at minimizing plastic pellet leakage into the environment. And then finally in 2024, Plastic Waste Management India, they come up with those sort of, some sort of modification in the existing rule. These rules emphasize reducing microplastic by promoting biodegradable plastics and a stricter criteria for plastic manufacturing as well. So not only those public sectors are very active, these private sectors are also coming up heavily, particularly if we look at the developed world. So these private sectors are actively contributing to this global effort, this particular effort to tackle this microplastic pollution through innovative solutions, as well as partnerships, as well as their commitment towards these particular issues. So what we learned today, particularly in this particular class, that basically we talked about those extended technologies of your plastics, how those these plastics can be reused, whether it is well or whether it is the other material which you can always use using those extensive technology or those infrastructure that we have tried to understand. At the same time, we also discussed on those particular the legal enforcement across the different parts of the world, that what are those legal impositions and what are those legal acts which is being enacted, particularly to look into these greater details of this or addressing this particular plastic management, as well as we have also seen the Indian effort, or how the government of India is coming up with those, whether you talk about PWM 2016 or whether you talk about Swachh Bharat Abhiyan. So these are all those efforts or initiatives that have definitely is going to contribute to this particular plastic waste management, this particular drive. And for your further reference and this for your reading, so definitely you can go through with all these references, and for this particular week, this is the 6th week. So you can go through all these references, as well as some of your books which will be useful for this particular the series of lectures which I have deliberated during this 6th week. Thank you very much.